All right, so let's get rolling. Homework for today was to create a little guessing game that bounced back and forth between some guessers, and I gave you some constraints. Let me get into my project. Is this the starting code I gave you? Okay, so you had to start off with something that looked like this, where main generates a random number, we get a secret number, we create an instance of this thing called Game Master, which doesn't exist yet, but I've told you that they're going to make that. And as part of the constructor of Game Master, you're going to pass that secret number into it, and then you're going to tell that Game Master to play the game. And the way the game works is you're going to have two different threads who are going to go back and forth guessing at a number, checking against the number. The game master kind of makes sure they take turns or whatever, and they are both guessing against the real number, and whoever guesses the right number first wins. That's what we spit out. Does that sound about right? So let's start unpacking this and start building this out. So the first thing we need to do, I mean, if we run this code right now, it's going to scream at us. It's going to scream at us because this guy doesn't exist, Game Master. So we got to write a class called Game Master. So let's start with that. So we're going to create a Game Master.java. So this will be a public class Game Master. All right. Go back to driver here. We see that the constructor for Game Master is requiring an integer. What number does that Game Master know about? All right, so we're going to create a private field up here. Call this guy secret number. Then we'll create a constructor for our game master. And this guy will take in our secret number, and we'll say this dot secret number is equal to secret number, thing that was passed in. All right, at this point, our game master now knows about the secret number. So by having the game master constructor take in an int, we now have made this line legal. All right, next thing, game master seems to have a method called play game. Is that going to be a static method or a non-static method? Go ahead. Non-static. How do you know? Yep, we're using GM to call it. So that's an instance of Game Master instead of the Game Master class itself. So that means we would go into Game Master here. We're going to create a, doesn't have to be public, but I'll make it public. And we are not catching any value here. So at the very least, it looks like it's not returning any value. At the very least, we're not using the value it might return. So that means it's going to be void. What's it called? Play game, capital G. So play game. And this guy took in no parameters. So we're going to make it take in no parameters. And then for right now, we'll just do system.out.println or something like that. Okay. So back out to main. We imported random. That allowed our random number generator thingy to work. Generator secret number, created an instance of Game Master using the constructor we just built. And then we call upon this method called play game that we also just built that currently just prints out woot to the screen. So if we hit run right here, we should get woot to our screen. All right, so we got working code now that doesn't do what we're supposed to have it do yet, right? Okay, so now we've decided that we should have a couple of threads that are going to be our guesser guys. Okay, so let's go ahead and build our guesser threads. You could have called these worker bees again or whatever you wanted to call them. So let's call this, we'll call it a guesser thread. So guesser thread.java. That's going to be a public class guesser thread, and this guy's going to extend thread. We want it to be one of those things, which means that we're going to have a public void run in here that does something. We probably want our guesser thread to have some way of identifying itself. So maybe we give names like Mike and Dave or something like that. So we're going to say that a guesser thread is going to have a private string name. Let's leave it at that for a moment. We're going to create our constructor for this guy. So that's public guesser thread. This will take in a name as a parameter, and we'll set this dot name is equal to name. Okay. And then for right now, why don't we go ahead and have our threads just maybe print their name and then wait a second or something like that. So we'll have this guy go system.out.println this.name. And then we'll say, I believe it's thread.sleep, but let's just go ahead and bring it up in the documentation for academic purposes. Yeah, I'm pretty sure it is, but this gives us practice reading the Java documentation.
And then you can decide like how long you want it.
Number of milliseconds is typically what it is. So I'm looking at the thread class here. So we had to dive in, look at the Java documentation. We scroll down. In my mind, I'm thinking, hey, I want my thread to pause or sleep or wait or do something. So I'm scrolling through here. I'm looking for something that looks interesting. Sleep. So we have a function called sleep. You can give it a number of milliseconds. So 1,000 milliseconds would be 1 second. And like, okay, well, that sounds like roughly what I want to do. Well, how do I call this guy? Well, this guy is inside the thread class, but I notice that he's static, which means he belongs to the class. So the way I call him is by saying thread dot sleep. So I'll say thread dot sleep. And we'll put that at 1,000. Just quickly, I want to jump into this. Okay, yeah, so we would have gotten an error if we were to run this thing right now. Let's pretend like we didn't look at this. So I'm going to leave the error in for a minute. All right, so right now I want my thread to print its name and then chill for a second. All right, that's all our threads are going to do. Are going to do for a moment. Let's go back to our game master now and let's just create a couple of threads and have them go and see what happens. All right, so we're going to go ahead and I called that guy a guesser thread. So we're going to say guesser thread GT1 is equal to a new guesser thread, and this will be Mike. And we have guesser thread GT2 is equal to new guesser thread, and this will be Dave. All right, so now we've brought those two guesser threads into existence, but we haven't actually started them yet. So since both of these guys are threads, since guesser thread, extended thread, that means they come with a start function that we can call that magically does the thready stuff and ultimately calls the run method of each of those threads. So we'll say gt1.start, gt2.start. Who? No, I mean start. Because if you look at thread, the thread class has a function called start. This is the guy that does the magical talking to the Java virtual machine stuff, ultimately calling this run method. So indirectly, you're right. We do ultimately want the run method to call, but we have to do it by way of the thread start function that makes the magic happen behind the scenes. All right, so we tell each of these threads to start, they do their magical thing, and ultimately they both start running their run method. So what we should see, what we expect to see as we've written it right now, is we expect to see either Mike or Dave, whoever goes first, followed by a little pause, followed by the other guy, back and forth with about a 1 second break between them. All right, but right now we're going to get an error. So let's go ahead and see the error, because one of the things that hopefully you're starting to get as you're working on these assignments is, I would have said this last semester as well, inexperienced programmers, when they get errors, they typically don't read the errors. They just dive back in the code and start changing stuff until it stops giving you errors or or whatever. And that's not the way to do it. Even if you get a correct solution, if you don't know why it's correct now, you've kind of lost out on what you're supposed to be learning. All right, so we're going to go ahead and run this, and we're going to see our error we're going to get. Unreported exception, interrupted exception must be caught or declared to be thrown. So it points to it that this is in our thread.sleep thing. Okay, where did I call thread.sleep? I called it here in my guesser thread right here. And it's telling me that that dude right there seems to be throwing some kind of exception-y thingy. Well, let's go look back. So I thought I looked up thread.sleep correctly. So we go back here, we look up our sleep function. I'll click it, get a little bit more information. We see, oh, this guy was built such that it throws this exception of something bad that can happen. It causes the current executing thread to sleep, temporarily ceases execution for the specified number of milliseconds, subject to the precision and accuracy of the system. Timers and scheduler thread does not lose ownership of any monitors. It gives us this interrupted exception issue. If any thread has interrupted the current thread, the interrupted status of the current thread is cleared when this exception is thrown. So if something else has an external impact on this thread, which we don't anticipate happening in our application, but this code was written generically. So it says, look, if something externally starts, while I'm asleep, if something comes and pokes the bear, I'm going to scream about it. That's what that's saying. And because this guy throws an exception, modern languages like Java require us to deal with it, even if we pass the buck. It makes us say, okay, I get it. That's going to be somebody else's problem, so we'll just pass it or deal with it ourselves. So we'll go ahead and do it in the good programmer way. So we're going to go ahead and say we're going to try to do something. We're going to try to go to sleep. I hate the way it's defaults formats this. All right. Try to go to sleep. And if something bad happens, now we know when we looked at the documentation here that there's actually two different kinds of things that could happen. The one that they are actually requiring us to deal with is this thing called interrupted exception. So if we wanted to be very precise, if I click on interrupted interrupted exception, we see that interrupted exception is an exception, which is a throwable, which is an object. Starting to see under the hood how object-oriented languages are built. Now, we really only have to worry about the specific type of exception that arises. Exceptions are effectively the modern day way of gracefully handling runtime errors. Instead of your program just crashing, it can crash with a little bit of grace and still break. But it gives us the opportunity to deal with it in case something happens. Now, once you wrap your mind around exception handling, sometimes you actually can leverage exception handling like an if statement. And let me give you an example of that. So a program that I'm currently working on, I'm either going to do one thing or I'm going to do something else. I'm going to try to grab some attachment from a web page. And my intention is that there is an attachment that's there and I'm going to do something with it. But if there isn't an attachment there, I'm going to fall back to doing an alternative approach to something. So I could try to get the attachment, ask some if statement, and say, well, did I get it or not? And sometimes it's difficult to ask whether or not a value has a value. Maybe, is it equal to null, something like that. Or you can kind of leverage the exception handling model and say, look, I'm going to get the attachment thing inside of a try block. I'm going to try to get it. And if something bad happens in there, it's going to get caught by this exception handler. And then I'll just do the other thing in there. So you can kind of use exception handling sometimes almost like an if statement if there are exceptions that you think might be somewhat common. I looked for something on page, didn't find it. that type of thing. But in general, I would say most of the time, exceptions are things that likely will rarely happen because you're the one writing the code and you're probably doing this under a controlled environment. You know how your code's gonna be run. But the people who wrote this stuff had to generically put in protections because they don't know how people are going to use this sleep function and that kind of stuff. All right, so realistically, we don't really need to do anything special with this exception. We don't expect it to be a problem. We also don't need to deal with it by its a real name. The only time you really need to do that is if you have a try block that has 5 or 6 things in it where there's 5 or 6 different types of exceptions that could occur. Then you might want to say, well, if this kind of exception occurs, I want to do this. If this kind of exception occurs, I'm going to do something else. If this kind of exception occurs, I'm going to do something else. You can have a whole bunch of catches. Catch this exception, this exception, this exception. In our case here, we don't expect to run into any exceptions. We're certainly not going to deal with specialized exceptions. So we're just going to catch anything that's an exception. So we're going to say, okay, I'm going to try to do this. If bad things happen, I will catch whatever kind of exception it was. And we can just do a system.err.println. You don't have to do the system.err. I'm just driving home that idea that there are 2 different output streams. And a lot of operating systems will use the error output stream for logging. So we'll just print out whatever that exception is. As we're writing this code, we do not expect that to ever happen. But if we don't put it in there, Java's going to continue to scream at us. This potentially thread.sleep, which we didn't write, throws an exception. So we're required to deal with it. Either deal with it locally here and be done with it, or we can throw the exception here, which then throws it up to whoever called this guy. So I'd have to deal with it again inside of game master, so on and so forth. So the correct thing to do almost always is to throw it inside of a try catch. So we're going to print our name, try to go asleep for a second, fully expecting it to actually work. We're not going to get an exception, and it's going to keep going like that. What does Game Master do? Creates 2 threads, tells them to both go. Now, when I run this, it should bounce back and forth between Mike and Dave at a 1 second-ish. Oh, I didn't put it in an infinite loop. So they did this exactly one time where in our thread, what happened is Mike said, hey, I'm Mike. Then he chilled for a second and then died. That's what currently is going down in here. So we're going to go ahead and we're going to say while true. We're just going to do this forever for right now. We'll take our code. We'll throw it in there. So now forever, print your name, wait a second, do it again. Now it should do what I advertised. All right. It is still printing them. It's just, okay. So now we got these 2 threads going. They're not doing anything for the logic of our assignment yet, but we got them doing something. So now what do we want to do? We want to have the ability for our each of our threads to make a random guess at a number. Okay, so let's start with that. So we already saw out here in driver how we generate a random number. So why don't we go ahead and teach our threads how to generate random numbers? So I'm going to go ahead and steal this java.util.random because we're going to need that in our thread. He's going to have access to that as well. That's something that the Sun Microsystems people wrote, built into the language. So perfectly reasonable random number generators. But if you are doing this for some kind of high-end simulation, you might want to use one of the random number generators from like one of the cryptographic libraries. Those have a better mathy thing, but for our little guessing game, we're going to keep national security at a minimum. So we'll come into our thread here. We'll make sure we have access to that random. Good.
Yeah, I was working on this code and I didn't realize that I didn't have the import Java util random in the guesser. It didn't work because you need it for everything. So
well, let's look at the error. So let's play it out. I've forgotten to put it in there. All right. So now inside of our run here, I'm going to say random r is equal to new random. So I'm in good faith going and trying to create a random number. I gave you some code here that allows it to generate a random number. So what we'll do is we'll say, call this guy my guess is going to be that. And then he's going to print out his name. And then we will also do something like guesses. Let's make that an arrow. That'll look awesome. And we'll concatenate onto that my guess. All right. So now every single time through, what are our threads going to do? Well, they're going to generate the random number generator one time. It wouldn't break anything if you put that inside the while loop, but it's pretty inefficient. You need to generate a single random number generator. You could actually just generate a single one, period. In this case, we're generating one per thread. So each thread gets its own little set of dice, if you will. And then every single time through this loop, he rolls the dice. And he's just spitting out his name, followed by what he guessed. Okay. So as of right now, we're putting ourselves in his shoes, and we have forgotten, we now know, that we've forgotten to put the import random, but we're going to run this not knowing that we've forgotten that. We'll go ahead and run it and look at the error we get. We want to have this practice of actually looking when we see red. We don't just view it as a gunshot wound and start diving back into the code and making changes. So we look at it and says, okay, guesser thread on line 14, cannot find symbol, random. He's never heard of that dude. Okay, well, what's the problem? Well, he doesn't know about random. Well, let's go back and make sure we understand our code. And we go back to our original driver and we see, oh, I imported random up here. That's probably how he learned about that. So I can take that, bring it into my thread, make sure my thread also has access to that. So that seems to address the problem it's complaining about right up there. Notice the other errors are also dealing with the same thing. Not only does it not know about the class called random, it also doesn't know about a constructor named random. So basically, it doesn't know about this dude named random. Now we've updated that. Go and run this again. And we have it generating random numbers. All right. Now we're not comparing those random numbers to anything. At this point, we just have two guys who like to say their name or some random number and take a nap for a second. That's all that's going on. Okay. So now what we need to do is we need to have a way for each of those guessers to let the game master know what their guess is so that the game master can decide, is that a good guess? Or is it a bad guess? Did you match my secret number? Okay, now, several different ways you could have accomplished this. So kind of the goal of this assignment was to get to this point where we're at right now, call it as quickly as possible, and then decide how do I want to manage my communications between my threads. So we could let the threads know about each other. But right now we have the game master knows about his number. We have two threads that each know about their individual numbers. We want to say, well, how does this guy make a guess? And then let the game master know if that guess was right. And if it is, how does this other guy know that he now lost? Okay, you got these two threads running independently, just sitting there spewing numbers out in the air. Okay. And when one of these guys finally guesses the correct number, not only does he now know he guessed the right number and he awards himself the winner, or the game master says, hey, this guy's the winner, all the other guys die as well. All right. So one way, if we're kind of going off what we did last class, is we might say, well, we could use a singleton. We could create this centralized place where maybe our game master stores his secret value so that our threads have access to that secret value, something like that. So let's start with that. So I mentioned I usually call my singleton core, whatever, name it whatever you want. All right, and inside of my class core, I'm going to have a static int secret number like that. And I'm going to go ahead and set that value by my game master. Now, this guy is an int, but he's static. Go ahead. Sure.
The game master constructor in main so that the guesser will come first.
You want to move this to there? Well, that's not going to work because we haven't invented GM yet. So we can't use GM to call play game when GM it doesn't have a value. But to your point, because it sounds like you wanted that to come first because you're seeing things appear out of order. That probably means that you have a lot of your logic here inside the constructor for Game Master. Not necessarily a horrible problem, but consequences of those decisions. If you put a bunch of stuff inside of constructor, well, those things are going to happen as this object is being built, not after that object is being built. Make sense? Not a right or wrong thing, just that's why it's working the way it's working. In core, so we created a way to remember our secret number. We haven't set it yet. We've made it an int. We've said it's static, which means it's owned by the class. So because it's static, we know the way we access this guy is by saying core dot secret number. So what we're going to do is go into Game Master, and as soon as Game Master finds out about the secret number, he can go ahead and say core dot secret number is equal to secret number. So he's letting that guy know about it. In fact, at this point, we could even make the argument of, does the game master even need to locally remember his secret number? Maybe not. I mean, because right now we're taking our secret number one time and we're putting it in two separate places. You know, I'm like writing it on a napkin and putting it in my pocket. And then I'm also letting this dude up here know about it as well. So maybe that's necessary for the way you wrote the code. Maybe it's not. But for right now, hey, let's not create extra lines that we don't need it. So now we're going to say, Game Master, you don't have to locally remember the secret number because you've stored it up in the singleton. So when a Game Master is created with that secret number, he's letting the singleton know about that number. And by that singleton knowing about this number, that means all the guessers now also have access to that number. So if I'm in my guesser thread and I guess, I put my guess out there, I can then ask the question. If my guess is equal to core dot, what's it called? Secret. Is equal to the secret number. Print out this dot name guessed right. Something like that. Okay. Now let's not take it any further than that right now. All we've done is our individual threads, they are currently guessing at a number. They're displaying to the screen what their guess is along with their name. Then they're asking the question, was my guess equal to the secret number? If yes, I'm just going to print out my name and I guessed right. I'm not stopping the program. I'm going to keep guessing. In fact, I'm going to move on and do it again, but let's see if we can detect correct guesses. That's all we're doing here, right? We're looking at the guess that the person just made, comparing it to the guess that the game master stored in the singleton. And if those are equal, then we are going to do that. Go ahead and run this. We probably want to take that 1 second wait out of there. Have them kind of turbo this a little bit. So here, let's just do that. Since we're not sleeping anymore, we technically don't need the try catch. So we'll dump that guy. Because now it's just a free for all. They're just going to do their guessing. Yep. All right. So they're going through. It looked like somebody did get a correct answer there somewhere as it went through, but they're not stopping. Right? Okay. So now what we can do is just continually evolving our code here. We're going to say, well, if I got the right guess, I probably don't want to keep guessing. So if I got the right guess, I can go ahead and get out of this infinite loop. So this particular thread, at least, can exit that loop. We're not communicating to the other thread at this point. The other thread, from his perspective, thinks everything is, yeah, game's still on. He determines he's the only one guessing. All right, but at least the thread who got it right will bounce out. The other guy will keep trucking. So we see here that Mike, Dave won pretty early on, it looks like, and Mike kept trucking for a little bit, just making random guess after random guess. Right answer was 32, it looks like. Now we do see here, though, that Dave didn't get his, when Dave finally guessed correctly, he wasn't actually able to get that out onto the screen until Mike had actually finished. Why do you think that is? Talked about IO being expensive, and these two threads are acting completely independent of each other, not communicating with each other at all at this point. All they're doing is checking their individual guess against something that's up on like a board, right? And so we're at the mercy of how the computer's operating system is scheduling these threads and that kind of stuff. And since IO is expensive, Dave said, "Hey, I want to yell to the rafters that I guessed right." So CPU says, "Hey, no problem. Get in line to do your IO." And while you're doing that, Mike's going to keep going for a bit. And then finally, Dave got his opportunity when Mike finally got the right guess. And he went to say, "I want to say I guessed right," which then allowed Dave to get back onto the CPU and print out his answer. Not necessarily a problem, just that's the rationale on why Mike kept going even after Dave had already guessed right, and Dave wasn't able to announce he guessed right till later on. Okay. So now we have a way of detecting that we guessed right. We're trying to display stuff saying that we guessed right. We see that we're kind of playing this game when it talks to when it deals with displaying. But the we don't really need to play the race condition thing with IO in order to accomplish this task. So what we want to do is we want to think about, well, first of all, there's a couple things we want to accomplish. One is we want to have them take turns. Mike, Dave, Mike, Dave, Mike, Dave, Mike, Dave. At this point, we don't have to decide who goes first, but one of them should go first, and then they should alternate from that point forward. What we might do here is we might create a function here, static, and do something like maybe this guy is Boolean. And we call this guy check guess. And let's say this guy takes in a int guess and maybe also a string name, the dude who is making that guess. Or if you want to take in the entire thread, you could do that as well. But for right now, let's just take in a name. And what we're going to do in here is we're going to say if. Now, I'm going to type something here. You tell me if this is allowed. Can I say if guess is equivalent to secret number? Am I allowed to write it like that? Okay, why? That's correct. I can write it that way. Why don't I have to say core dot guess? Or why don't I have to say core dot secret number? Why was I able to just say guess equivalent to secret number? Go ahead. Uh, that is a true statement. It is being shared by all the classes, but that doesn't tell us why we don't have to explicitly mention core here. Static. So because this guy is static, and because this guy is also static, while we are inside of this method, we are in a static context, which means we don't have access to something called this, but we do have access to all the things owned by the class we're currently in, which is core. If I were writing this, I still would say core dot secret number. I like to be explicit. All right, but it's not actually required. So what this check guess does is it takes in a guess and the name of the person who made the guess and checks to see if the guess is the same. If it is, it maybe will print out something like system.out.println name guessed right. Something like that. And then it might also do a return true in case it wants to report that back to whoever called this guy. We're not calling it from anywhere yet, but that's how we designed it. We designed it to return a Boolean. Now, if we didn't guess right, we're going to return false. All right, so that's what this function does now. Takes in a guess and a name, checks it, boom. So if we go back to our guesser thread, instead of us checking our guess locally here, what we're going to do is we are going to call core dot check guess. And we're going to pass it our guess. And it also is expecting us to give it our name. And the name for guesser thread is going to be this dot name. So whichever thread called this is going to call core dot check guess, passing it the number he's guessing and his name. That function is then going to compare who, compare it against the secret number. This does rely on our game master previously setting those things. We know we did that. We know the very first thing we did inside a game master is we let the secret number know, core secret number set it equal to the number that we're checking against. And not until we played our game did we start spinning up threads. So now each of those threads will pass their guess into there along with their name so that core can then police the guessing and say, hey, if whoever just called this guessed right, we're going to go ahead and print out their name and say you guessed right. We'll also let them know that you guessed right by returning true. Otherwise, if none of this happens, we're going to return false. So in our guesser thread, we are making that guess. Now, we probably want to find out, did we get it right? We know it's going to be reported to the screen that we got it right. But if we want to make sure we don't keep doing guesses after we got it right, you probably want to wrap this if statement. So if we guessed right, then get out of here. Break out of the while loop. So if this guy right here boils down to true, if it returned a value of true for us, go ahead and break. All right. So now we're going to have pretty similar output to what we had before. although the mechanism by which we're getting it is a little bit different. All right.
Giving Michael.
Yeah, we're going to do it here in a second. So we see up here at some point, it looks like Dave guessed right a while ago, and then Mike kept kicking. So really, what you're asking is, how do we get them to all stop guessing as soon as somebody wins? Right? That's the punchline here. So at this point, we have a couple different problems. First of all, we have no guarantee, although with only 2 threads, it's probably fairly probable that they are taking turns. They're going back and forth. But if we really want to guarantee that, we would come into core and we would say that our check guess is synchronized. What that does is it, as we saw last class, is this makes sure that 2 threads can't access this function at the same time. So if 2 guys are trying to get it at the same time, Java will figure out who won. That person will get that resource, and Java will tell this guy to wait, and he'll manage the whole thing. You don't have to do anything special. He'll just say, thread, you lost by a hair. We'll get to you in a second. And then he'll be able to call it. So at that point, we guaranteed control access to this one resource. All right. I doubt, like I said, I doubt very much this actually is going to make a difference in our output. In this particular case, only dealing with 2 threads. But if we spin this up and we have 1,000 threads all trying to make guesses, this could be a bigger deal, right? All right. So right now, check guess only gets called by one person. We have the ability to check. We return back to the threads to let the individual threads know, did you guess right? But that does not let the other threads who didn't guess right know that the game is over. So how might we accomplish this? Well, one thing that I'm guessing you probably didn't do, and this is somewhat of a hack, but I'll show it to you because sometimes this is a convenient way of solving these problems. I'm going to go into the Java system class, and I'm actually only pretty sure this still exists. There's probably a system.exit function. Here, system.exit. So you just kill the program, which would then cause all the threads to also die along with it. This isn't what I necessarily intended your solution to look like, but it's fine. So we could do this system.exit. It does require us to give it an exit code. And where have we seen that before? Remember back in the previous course when we were working with C++, main had a return type. And at the end of main, it would always do like a return 0, return 1. That's what we're doing here. We're the ones who are telling our program to end with a return type. Go ahead. But if I do a break here, well, first of all, a break in this particular case, if I put break here, what's that intending to do? Yeah, we're not in a loop. Exactly.
Sorry.
No, that's perfect. You asked the question, you answered it yourself. Those are the best kinds of questions. Yeah, but yeah, break makes tons of sense if we were in a loop and needed to get out of it. Go ahead. Technically, what it does is it ends the top level thread, this running program, whose child threads are sharing its resources. So if that guy's dead, all the children die off too. This is not a very controlled way of doing it. It's a kind of medieval times type thing, but it's going to get the job done. With that in mind, we also don't even need to return values because our threads are not going to get these answers. But well, let's see if it lets us, because it's probably not going to view that guy as exiting the program. So it probably is not going to yell about that for the moment, even though we happen to know we're not going to get to that next line. All right, so we get Mike guessed right. We see the back and forth there for a while, and we get our final solution, whatever. So in that case, Mike did win and nobody else went. Probably not the way I would have intended you to do this, but just kind of showing you if you ever need to bail out of a program instantaneously and not have to worry about the aftermath. You're not in the middle of backing up your program to a database or something like that. Doesn't matter where you are in the program, you can always just bail with a system.exit. Go ahead. Yeah, so core, I refer to this, I'll just put it in a comment here that because I will upload this code, but this is something I call a singleton. Singleton is our design pattern that says it's a good idea. And I see we only have 2 minutes, so it's on my mind. It's a design pattern that says it's a good idea if you have information that needs to be accessed by multiple entities, you put it all in one place. All right, so that's what this guy is his purpose is for. I named him core. You can name him whatever you want. But the important thing about this is notice inside of a singleton, everything is basically static. It's owned by core. So it's core.secret number, core.check guest. And we can access that from any of our other classes. So in some ways, it's a little bit of a cop-out. When I introduced this originally, I mentioned that, design patterns are a much newer thing in object-oriented programming. And historically, they might say global variables are bad. And in general, you don't want to just throw everything global because it magically makes your program work. That's not the right reason for it. But in this case, we have, a game master. We have 2 child threads that all need access to these secret numbers and all this other stuff. If you could just throw that all up there, it's going to make everybody's lives easier to just be able to work through that singleton rather than having to pass information around or having thread A tell thread B to shut up because you lost all this stuff. All doable. We have all the tools to do it. This is kind of a better way of accomplishing it. All right, so I'll stop here. Let me actually, I'll put this code up on Slack so you have the current version. No assignment for Friday, but there will be assignment over the weekend. I'll come back on Friday and I'm going to finish solving this in probably the way I more think you probably solved it. I just because of the time, I threw the little system.exit curveball in there, but this is a nice little hack for you. All right, questions, comments, concerns, bribes. Well, good. That means I did my job. Now you go back and listen to the lecture 50 times over until it all gets sunk in. All right, I'll see everybody on Friday. Well, good, but you're still walking. That's it. Exactly.